Hello, everyone. In this video, we're going to learn about the difference quotient and rates of change. So in this first part of the notes, we just have some definitions. So the first definition is the rate of change of a function. The rate of change of a function, let's call it f here, on an interval from x to x plus h can be found by computing the slope of the line between the points x, f of x, and x plus h, f of x plus h. So we see this on the graph below. So let's look at this visual here. So on this visual, we have our graph of f, and then we have 2 points marked on our graph. So those points are x, comma, f of x, and x plus h, comma, f of x plus h. So if we want the average rate of change over this interval from x to x plus h, we compute the slope of this line here. And we can make sense of that because what that slope is computing is the changes of the output over that change of the input. This line formed from these 2 points is called the secant line. So I'm going to fill that in here, secant line. And it's labeled here on our diagram as well. So in other words, the slope of the secant line is the average rate of change on the interval where we're looking at those 2 points that the secant line is going through. All right, and then the last little bit of notation or vocabulary here is the slope of the secant line, like we were just talking about in this first bullet, through these 2 points is often called the difference quotient. So again, below is a picture of the situation. So what you're noticing here is that there's a lot of repetition. And that's because in these definitions, there are many ways to say the same thing, meaning rate of change of a function over an interval is the same thing as the slope of the secant line, which is also often called the difference quotient. So before moving on to the next videos where we look at some examples, let's go ahead and compute that difference quotient together. So again, that difference quotient is just going to be the slope of the 2 points, slope between the 2 points that I have labeled here and here. So recall the slope is going to be the change of y's over the change of x's. So to do that, we can first compute that change of y. So we can use the y value associated to the x plus h point. So that would be f of x plus h minus the y value associated to the first point, which is f of x. And then in our denominator, we have the x value associated to that second point. So that would be x plus h minus the x value associated to our first point, minus x. So now how can we clean this up? Well, we see that in the denominator, we have an x plus h minus an x. So those x's cancel, and we're just left with f of x plus h minus f of x all over h. So here is the simplified difference quotient. And now I just want to make a quick note about why we are computing this difference quotient. So a look ahead. So many of you might be taking calculus after this course. And in calculus, we are interested in what happens when the h in this difference quotient gets very, very small. So imagine our picture up here where we had our secant line. Well, when h gets smaller, this point over here scoots closer to the x. So what happens here is our secant line changes on our graph, and as h gets closer and closer to x, then we get a line here that's very close to what our graph actually looks like when we zoom in. This line you'll learn in calculus is called the tangent line. Again, you don't need to worry about this in this class, but I want us to get some motivation for why we're looking at this difference quotient. So when we compute the tangent line, or rather the slope of that tangent line, That's what we call the instantaneous rate of change of the function. This is often also rather called the derivative at that point. So to find that value, we compute the limit as h goes to 0 in the difference quotient. And as I said, when this happens, that secant line approaches that tangent line. And when computing that limit, the first step that we need to do is to simplify the difference quotient. Again, we won't be worrying about this part in this class, so don't worry if all of these words are new. They most likely are. But I just wanted to give us some importance and context for why we care about that difference quotient and why we want to practice simplifying it. In the next videos, we'll look at some examples of how to simplify the difference quotient with some different families of functions.